How are you doing? It's getting late, huh? All right. Aren't you glad I'm the last speaker? Okay. All right. Welcome to Practical Performance Tips to make your app, website run faster. My name is Doris Chen. I'm a developer evangelist at Microsoft. And here's my contact information. My email, typical Microsoft standard. And my Twitter, Doris T. Chen. Make sure you put a T in the middle because I'm getting complaint. People say they ask me something, right? But I never respond. That's because I never get it. You put it to Doris Chen, right? I don't know who that person is. Doris T. Chen, that's me. Again, I've been with Microsoft a little over 5 years now. And that's funny. Should I be there for 10 years? Okay, all right. Okay, that's fine. That's a good feedback. All right, so, and I'm local. I'm based in Mountain View, and it's good to see you again. So before that, I was a Java evangelist with Sun Microsystem for about 10 years. And then I'm a web person, basically. But I love performance tuning because when I joined the Sun, my first project is actually doing the Java performance tuning. So now I'm glad to share with you some of the tips I learned from HTML, JavaScript apps, and the webs. All right, so really, this is, I actually offered a free course on this subject. It's like a whole day course, right? So I try to extract about the content for 45 minutes. Just hopefully I could make it. Let's see how many stuff we could go through. So it's going to be a little fast pace. Are you ready for it? Good. So first thing we want to think about is we're working on the sites and apps running on modern browsers or mobile devices, right? So what are the things we care about? So first thing we probably will look into is you probably will say, the bandwidth, right? So if you look at it, you probably have mobile devices with different carrier, with different bandwidth. But usually, let's say if it's after 5 megabytes, it's pretty good. It's not bad already, So bandwidth, maybe you have a really low carrier, maybe it's a little slow, but once you get into like a 3.4, 6.1, especially 4G, it's good enough. But the things we really sort of look into is a network latency. So what is network latency? Let's actually do a little experiment. Okay, you follow what I do. Okay, let's try one more time. Okay, you hear the delay, right? Now, again. Okay, so I clapped twice. What I try to mimic here is I try to increase the bandwidth twice. But then actually the delay is still there. Even though I do clap twice, I do increase the network bandwidth. So the network latency, the delay will always be there, regardless of your bandwidth. So this is really something we want to really look into, which is the network response time. Okay, so this is something we want to sort of look into a little bit to help you make your code have better network response. So this is speed and responsiveness probably is one of the most important things. People see your site, people see your app, right? So I usually say there is a real sort of like response versus a perceived performance. Anybody understand what's a perceived performance? Good. So you click on something, right? You're expecting to see something, hopefully right away. But there will be some delay, right? So I'm trying to use this diagram to show you how does that loading time versus the CPU utilization. So normally, time to grasp meaning user initiate an action, click on a link or click on a button, and then until you just start to see something. Right, start to see something. So this is basically time to grasp. This is something we have to do it really, really short. Otherwise, your user will lose confidence in your app. They think your app is not working or your website is not working, right? And then afterwards, it's basically the whole elapsed time is truly the page start to load until it's finished loading. That's the whole time, right? That's also very crucial. That's important. And then the time I'm talking about, the CPU time, is truly the CPU is working hard, it's reached the full capacity. That's actually the CPU time. Now, in reality, you would love to have CPU run all the time, right? Fully utilized. But then, as a matter of fact, you do see quite a lot of dip and idle. So this is what we call CPU idle time. So what does that mean? That means if you have a lot of CPU idle time, your response is going to be slow. So for this talk, one of the key points here we try to do is reduce the CPU idle time and then improve the parallelism. Reduce the CPU utilization. You make sure the idle time is really, fully. Basically, we just say we want a CPU run all the time. We don't want it to get stuck with a thread. We don't want to say it's a synchronization kind of issue. The CPU could not do anything, have to wait. All right. So this is the whole idea. So these are the things we also need to look into: CPU utilization. Now, another thing, especially with all the mobile devices, right, all the tablets, power is important. Power consumption. Because why? Because power is really, the capability of using a power, the battery life, directly relate to how happy you are with the device, right? So, and then you look into the power consumption, it's actually all related to the VSync. VSync which is a hardware kind of parameter. And the maximum, the speed it could get is 60 frames per second. That's the maximum it could get, right? And then the other thing is GPU utilization, and as well as CPU utilization, right? So now I'll give you the example. Usually, we could actually have a power or device use up to 5 watts. After that, your device is getting really hot. It reaches what's called thermal mitigation, and meaning it's just device is not functional. Reach some threshold, it's not going to perform very well, very slow or things like that. So it's very easy to reach your 5 watts, right? Anything you want to engage with GPU is 2 watts. Anything you want to use 1 core, it's 2 watts for this, say 1 core of CPU, it's actually 2 watts. Another 1 watt could be used some kind of antenna or something. So 5 watts is really easy to sort of like reach. So the things you have to really think about is how I'm going to actually save my GPU usage, my CPU usage, so that I could have a better power consumption, better battery life. This is very crucial, right? So GPU, CPU, VSync, these are the things we actually want to look into in this session. Okay, you're probably wondering, what kind of tools could I use to measure, right? And we talk about, it's basically a browser application. Doesn't really matter what tools you use something you feel it's really useful. But I like to share with you the tools I use, right? Which is F12 tools, which actually Ray actually showed you earlier. And then F12 tools is really cool. Do we know what we call F12 tools? It's actually part of IE and also the new browser Edge. You click on F12 function key, you have a develop tool, right? Let's actually show you if you never heard about that. So this is, say, I have a browser. Let's say this is the Edge, right? I click on that. Let's see. I have to open a new one. This is probably just a tab. Cool. Okay. So let's say, for example, oops. Okay, let's try it. Let's see where you want to go. Let's go to Amazon. Here you go. Thank you. And then I could actually, when I have a real page, right, then I could actually go to my developer tools. Right? And let's see. They just show me a trick how you could do this. All right. Okay, so for example, there's a lot of things like a DOM, Explorer, work with console, debugger, measure your network, just like a fiddler, right? And the one I'm really want to look into is the performance. All right, so for example, I will start a little profiling. Oops, that's too soon. Not much traffic yet. Let me try it again. Start, And let me click on something, generate some traffic here. All right. Okay, so let's make it a little larger. So what you see here is your CPU usage. And different color meaning different things, like the loading time, page loading, the scripting processing time. The yellow means garbage collection, starring, rendering, and so on. So you could actually, according to the color coding, to find out what are those things really consume your CPU. Now, what's really interesting here is this UI responsiveness. In an ideal world, you would love to see everything is 60 frames per second. You would like to see all those bluish area is like a flat, right? That means 60 frames per second. That's the fastest you could get. That means everything is so responsive. But then you do actually start to see quite a bit of like a little dip here. That means your CPU, your response is actually quite slow. You actually start to see some delayness. And with this tool, it's very easy. You could actually zoom your dip, and then take a look what's really going on. Go down to each one level, and they will actually tell you what's going on with your request, with your particular method, and you will see what's the most expensive method, and so on. So this is actually a really cool tool. I'm sure you could use some other tools, right? But I prefer to use this one because I see the user responsiveness. At the same time, it really correlates to what's going on, with CPU, what's going on with your code, with the Java method, with your JavaScript library to see which one may be slow. So this is really something I use for all my benchmark. Isn't that cool? All right. All right. Okay. So let's continue from there. All right, so this is the F12 tools. I just did screen snapshots. It's available on IE11 as well. In IE11, it's called UI responsiveness, but it's the same thing as like in the Edge I just showed you. It's called performance, the same feature. The other one is very classical. It's Task Manager. Task Manager will actually let you to see the CPU situation. I just use very simple tools. They're all free, right? They're part of the Windows or a part of the browser. Okay, so these are the two major tools I use for all my benchmarks. So let's actually get into further, how I'm going to actually reduce my network response time. How I could quickly respond to the network requests. There are quite a lot of tips, but I just choose a few of them to share with you. First of all, you try to avoid redirection. How many of you here are doing redirection for your sites? Anybody? Okay. Now, as a matter of fact, you don't want to do redirection just for the convenience of it, because it's going to slow down your response. It could slow as much as 250 milliseconds. That's almost like 10% of your performance degradation. So you should actually watch out if you don't have to use redirect. Or some of you, see, there's only one person say, I use redirect. He is brave. The rest of you may not even realize you're using redirect, because I show you the statistics. 63% of the top 1,000 websites are using redirect, 300 level redirect. So check your website. Maybe you're using redirect. You may not need it. Why you have to use redirect? Right? Just look into it. There's a lot of things that's just there, and you just never thought about that. But it's going to slow down, say, 10% of performance. Why you want to keep it there? First tip. Next one is we want to actually maximize our concurrent connections. And this is actually pretty important, because normally you would think, client web application to the server, that's just kind of one-to-one kind of round trip, right? That's just one connection. You're only using one connection. As a matter of fact, you could use multiple connections all at the same time. Do you know that? Give you an example. Starting with IE9, we already have 8 concurrent connections you could make. So I would say, let's just say you make 6 concurrent connections, right, with the server. For most browsers, you should be able to provide at least 6 connections. And then you could have multiple domain to access that. So if you do the max, 12 connections you could use at the same time to loading your resources, to loading your images. That's very cool. That's very good, right? So then you ask me then, how could I make that happen? I want to do that, right? Very easy. Make sure in your HTTP response, make sure you don't really close your connection. Because once you actually close your connection, you cannot really reuse all the connection, right? So you have to leave it open, right? So you could actually leverage all the concurrent connection at the same time, getting more resource downloaded much faster, much efficient. All right, this is a very small change for you, right? Go back to check that. Check to see if a connection, if it open or close, right? I have to leave some homework for you to do. Okay. All right. The other subject we want to move on to is minimize the bytes you download. All right. Now, why we talk about that? If you look into the HTTP archive, this is a resource, right? And you will see what is the average payload. The average payload has 93 resources requests over 16 hosts. That's a pretty average payload. And then each of those page will contain 1.6 mega as a total size. As a matter of fact, it's a pretty big 1.7, right? But it's only 46% of them are cacheable. And you may want to look into the detail of those things, right? And then it's very consistent. What we see here is a blue area, the blue region. It seems like it has a lot of those sort of content. What is the blue region? It's images. It's all your images. So images play big role in your payload as well as the download size each page. So we probably have to be careful to work with images, right? Now, so next we're going to actually talk about that. Okay, so first thing we want to do is how we could, like I said, 46% of them is doing cacheable. So that means 54, more than half of the sites are not doing caching at all, right? So why is that, right? So is that something we could make it better? So one of the technique you may or may not heard of that, or maybe you already use that. It's called app cache, right? App cache is, how many of you use app cache? Okay, so how many of you never heard about app cache? Okay, how about the rest of you? Can you just put a hand for no reason? Just kidding. All right. Okay, so let me just briefly go through that. So every time you say your client, right, you're getting some resource from your server, say you have a page with all the images, audio, video, all the data, right? You get it, when it's online, you get it from the server. That's your resource. Then afterwards, this app caching mechanism is try to, based on the configuration, getting all the resources you want to save locally. For example, the images, the audio, the video, some of the heavy library, some of the JavaScript, whatever you want to save. So you could use app cache to save it, right? And then when it doesn't matter if it's online or offline, it could actually feed those resources, those content into your web page. All right, so this is really good, especially when you have offline, right? This would be a good app. And then when there is some change in terms of those resources, the app caching mechanism is they will check with the server, update all the resource, and then they will always get the most updated resource they want. So this is basically the mechanism behind app cache. And you may be wondering, just say, how hard or how easy to do that? So this is a very simple example. It's super easy to do. In the HTML level, you put a manifest, right? And associated with your configuration file for the stuff you want to cache. In this case, it's called test.appcache, right? And then this is actually external. Your manifest file, your test.appcache is really external. You could configure anytime. You could change it any way you want. Inside that, you will say, I want to cache the logo image. I want to actually, getting the, say, fish, it's an MP4 file from the network. I want to actually cache it. Or I want some fallback kind of images in case my app is not working, right? So all those things you actually captured in the manifest file, and you could configure it the way you want, right? Very easy. One mechanism to do is use app cache, and you could use for a lot of applications, both online and offline. Okay, so like we said, we're doing a little fast. Is it too fast for you? Okay, too slow? I could speed up if you want to. All right, okay. So the other thing is optimize the media usage, all right? So if you look at this, what is this number? The number we actually took probably 2 years ago. The number could be changed a little bit, but roughly the average number of media resource is 58 piece. We take the average for the top 100K websites, 58 piece of resource. That's quite a lot to work with, right? And then how we could actually make those resources more efficient. One of the things we notice is what we call native image resolution. Now, a lot of times, we actually we probably use same image, right? The original size is 500 by 400. And then maybe we will take some thumbnails in different size, right? And then in this particular example, our thumbnail size is 50 by 40. Now, there are multiple ways of doing that. And there is, you could leave the original size. You could define 50 by 40. You could define 20 by 30 by 20. You could define different thumbnail size. You could let the browser to do it for you. However, there is a better way of doing that in terms of performance. You could actually, not being lazy, but resize to the exactly size you want. From 500 by 400, you could downsize an image, a smaller thumbnail image, to 50 by 40, right? That way, you will be able to save a lot of loading time as well as the image decoding time. Right? So let me actually share with you the result we have. We actually have a test site. This is a website for the Build conference we did a couple of years ago. And then you see we have a lot of large, sort of like a size image. We have a little image row there. As well, we actually do have a little thumbnail image to talk about some other things, smaller size. So we did some tests. This is, again, most of the benchmark here on IE11. And then it's on our particular production environment. So I share with the benchmark to you, want to give you some direction, but I don't want you to take the hard number as it is. Because for performance tuning, one of the key things you should be aware is always test on your production environment. This is super important because it's not anybody trying to tell you this is faster. You have to test it if it's faster for you. All right? So I want you to be sort of aware of that. And then if you look into this particular scenario is, if you, so when you right size all your image, put it like a 540 to the right thumbnail size, it takes about 624 milliseconds. Versus I leave the browser to do the resizing for me. It takes almost 3 times more time than the resize one. And then the reason is it's very obvious. You see a lot of the blue bars here. Those blue bars represent image decoding. That's because all the big, large size image has to be downsized into the smaller one. But when they download it, they still have to do the image decoding. So it takes all the decoding time. So these are the actual time you actually don't have to spend on the decoding, right? You could resize it and make it a lot of links so that you could save almost 3 times as faster. So this is a pretty, I think, a useful tip or to share with you. You could go back to check your website to see if you have original size. You just leave it the way it is, even though you're doing a tiny, tiny thumbnail kind of image. You could check that, all right? Anybody want to try? No response. All right, okay. Probably, sounds good. All right, so the other thing is the size. If you look at the whole size, we also take some benchmark. You could see the size difference is almost half of them. That's measuring the internal memory allocation. So the memory-wise, you also save some memory to do that. Okay, this is something, it may be a review for you. So if you have a lot of icons, you have over 100 images, what are you going to do with that? Do you try to transfer one at a time from the server or what? Okay, so obviously we use something called image sprite, right? So if you look at this, this is just a very simple 6 kind of icons at a row. If you do 6 images, try to getting it one at a time, you make 6 connections, and your total download size is 96K. Versus if I kind of combine them into one image, and it only cost me 1 connection, and I only cost about 21K download. So that's much faster. Now, one thing I want to sort of give you a little tip is There is some image sprite tool you could use to generate that. But if you really want to save it to the best, you should actually manually generate, combining all the icons together, generate your image. Because use the sprite tool, sometimes you will generate a lot of white space. So you will still waste some space on that. So if you could manually generate that, you could actually save more. So image sprite, I highly recommend if you have a lot of image to do. And this is, again, the benchmark we took from the top one is actually the uncombined version, which costs about 210 milliseconds, and the bottom one is actually the combined version. We talk about a 1,000 image versus actually 30 kind of images, and we will see it's saved quite a bit, at least like a 40% of the time saving for the reduce the number of images and the downloads. Okay, use CSS3. So this is actually very interesting because a lot of people actually still not trust use CSS features. As a matter of fact, for performance saying, CSS3 markup feature is a lot faster than using any of the JavaScript coding, as well as you actually manipulate the image, try to create some effect like a gradient. Right? So if you need to create a gradient kind of effect, use CSS3 gradient. And on the same concept, you could also use a lot of other CSS3 features like the border radius, right? How many of you use the border radius? How many of you never use the border radius? All right. So my designer friend says, if your design is not rounded corner, it's not a good design. So I guess everybody should use border radius at least once for their design. So border radius is another good CSS3 feature you may want to do to have better performance, as well as CSS3 transforms, all right, the transitions, and then the CSS3 animations. All those things is going to save you tons of time instead of doing JavaScript or instead of doing just image kind of manipulation, all right? Okay, so markup thing. Now, I know like a lot of you heard about Steve Sauter's top 13 rules. He did it when he was still at Yahoo, right? So just pick a few very important ones. For example, you should always leave your style sheet on top of the page, right? No? Never heard of that? You know why? Okay, because if you want to have the initial response, you better actually tell the browser, the rendering engine, to get in the style sheet first, because then they know where to start to loading something, right? So that's why if you put the style sheet towards the end, you have a bunch of JavaScript running. It's not going to work because they have to wait for all the JavaScript finish processing. Then they could actually put your style sheet. Then you're going to see a blank screen, nothing to happen for a long time. So that would be really bad for your page response, isn't it? So always keep the style sheet at the top. And then the other things to pay attention is we usually work with a lot of pages. There's a home page, there is a sub page, content page. A lot of times you don't have to put your style sheet all at the beginning, because the first page, the first loading, the initial response is a critical time. It's actually the time your user will determine if you like the site or not, right? So if you don't really need that style sheet maybe it's for later use, right? You just put absolutely the minimum style sheet you need for that starting loading page, and then leave all the rest of style sheet later because you don't need them. All right, so that's another tip. If you go back to your code, I bet you put a lot of style sheets at the beginning because you just think, I want to make sure put it there so I could use it. Maybe it will cause some performance. You never know. Okay, the other thing is you want to leave your JavaScript to the end. Why is that? Same concept, right? Maybe your JavaScript is kind of heavy. There's a lot of code to load, to processing, right? And then if you leave in the beginning, then it's going to take a while to see something, right? So always put your style sheet at the top, your JavaScript towards the end, right? So this is always a very great general practice. Now, let's see why. So this is actually doing a little comparison. I purposely put the JavaScript in the header, which is in the top of the page. And this is what's going to happen, because See this big delay on the CPU? There's nothing going on in the CPU. Why? Because it's waiting something to getting the JavaScript to processing that and to fully load that. There's nothing they could do about it. Right? JavaScript engine is not going to do much because there's nothing. They're needing to wait to load everything there, right? So that's what happened. You will have a big delay because of the initial loading time, right? So now, second case is you put it towards the end. Then it's more healthy. If you look at a CPU, it does have a little delay, but it also working on something progressively. That way, you actually could see your page start to really show up, start to see something gradually. So this would be a much healthy pattern for the CPU utilization. Make sense? Okay, so duplicate code. This is a really interesting one. I know, like, if I show something like this to you, nobody would say, "Are you saying I'm stupid or what? I put a jQuery multiple times." You go back to check your code. I did that because sometimes I'm not realized I already put a jQuery library somewhere. I just thought, oh, I need a jQuery library. Let me put it again, right? That's what we call duplicated code, right? So this is a very simple example. Of course, you could have spotted it right away. Like you shouldn't put it again and again because it's really increasing your JavaScript library loading time, right? But then in reality, check your page. I bet one of the page you probably put a jQuery twice or even more than 3 times. So don't feel bad because 52% of page on the website, they do have duplicated code. So 52, more than half, right? So go back. This is another tip for you to sort of look into, see if you have a duplicated library there, right? Now, I think this is, there's a lot of frameworks available, right? There's a lot of new things coming out all the time, like Angular, Ember, React, Backbone, you name it, And a lot of times you may just want to play with them. You put there, or maybe you try to impress your colleagues, impress your manager to say, oh, I know everything, right? But try to look through your list. Try to think about it. Do you really need them? If it's for experiment, it's okay. But in the production final release, you should just keep on one single framework that you truly use. All right, don't list all the frameworks there, and don't really include so many scripts just because they're cool to see that Facebook, Twitter, Google, analysts, all those things, right? Try to keep it lean, right? And then we do have a benchmark for that, right? So the top one is you're doing number of frameworks all there, and you will see this garbage collection thing, the yellow things going like a crazy, right? And then also the JavaScript loading processing also going like a crazy in the brown area here. Why? Because you have so many libraries try to load, right? And they're wasting your resource because some of them you may not even need it. And then when you use single framework, of course, it's more normal, more healthy, right? So just be aware of all those simple things. It's maybe trivial, but it may happen in your page. Okay, so the other thing is, we want to know you really understand what your application is doing. This is really, it may be something you already know, but I thought it's worth to mention about, especially you want to actually, align a timer to display all those different frames. You try to display those things. There is 2 API. One is called set interval, set a timeout. How many of you are actually using that? Okay, so you actually parsing your animation, and then the crucial thing is to determine your time interval. What time interval do you put? Put a 0? Or larger than 0? Basically, 0 means keep on refreshing display all the time. So if you think about it, what is 60 frames per second? That's basically what's the maximum frequency human eyes could really see it, right? So if you divide by 1, divide by 60 frames per second, you get about 16.666 milliseconds. So that's actually the interval. If it's 60 frames per second, which is maximum kind of response, that's your interval should be just setting to 16.7 milliseconds. That would be the best interval you need. Because if you put a more refreshing interval, your eyes are not going to see. So you'll waste your resource of doing that, right? Now, but this is really, use set interval or set a timeout, but perhaps there's a better way to do is use request animation frame. How many of you have used that? Okay, this is a way better one because what? I don't even have to care about the interval. I let our browser to determine what will be a good interval to do the display. So if you call request animation frame, the browser will actually do the work for you. So you don't have to even worry about what kind of interval you put. So highly recommend if you need to do all those kind of display of frame, use request animation frame. All right, so the difference is huge. This is the one I use set a timeout with animation with zero interval. Basically means keep on display, keep on refreshing. So you use more than like a 75% of CPU utilization versus you use request animation frame. This is down to the 65%. That's actually save 10% of the CPU utilization just by one method switch. That's actually pretty cool, right? All right, so almost running out of time, but I want to just share with you really quickly how to write faster JavaScript code. You should always use JSON, right? Anybody still use XML representation? All right. One maybe for, I know like from the old SOA kind of time, we do exchange XML message. But if you can, use JSON because it's a lot faster. And it's actually has all the built-in JSON methods to process data, to parse the data. So that would be actually much better to use than any of XML data. The other things I want to mention is about numbers. Do you guys understand the difference between integer and floating point? Not from mathematical perspective, but in terms of number of bits. Okay, integers basically, untagged integers is only 61 bits. 61 bits of the data you could fit into stack. And we all know stack is more flexible, it's faster to access, right? Once you use 62 bits, basically mean you are working with floating points. The floating number has to take 32 bits. So once you reach 32 bits, it has to use the heap, which is quite a lot slower, right? So what does that tell you? Basically, that tells you if you can work with integers for your code, try to stay with integers. Avoid use the floating points because whenever you have the floating points, you have to move from the stack to the heap, which is quite a bit slower, right? So that's why when you're doing the math, in this case, this is the way you actually have to stay with A plus B divided by 2. If you work with a floating point, then most likely you have to actually work with not just stack, but a heap. But then if you could keep it as an integer, like this way, right? And then you could actually just work with stack, which would be a lot faster, right? So another tip I want to share with you is the chattiness in the DOM. I don't know, I think this is probably the last tip I will share with you, time-wise. I don't know if you see this particular one, document get element by ID, class list dot remove, and the next line is same thing, and then instead of remove, we say add this class, remove and add. If you're just running it once, it's not bad, right? But if you run it in a game, millions of times, billions of times, and then you keep it in a loop, you should not just doing that. What you should do is actually assign it to an element. You should only process it once. Why is that? Because if you go through all those things, right, from the DOM element, go back to JavaScript engine to call the get element by ID, then go back to the DOM, then back to the JavaScript engine, get back to DOM, you have to do all the switch, all the change, 1, 2, 3, 4, 4 or 5 times, even for one statement, right? And if you put it in a loop, every loop, instead of doing assign to an element, you put it there, you're wasting a lot of time just by doing the DOM and JavaScript engine switch. That's just not a good way of doing things, right? So the good way to do that is, actually, I would call it $1 million tip because people save a lot of time just by just changing one simple thing like that, right? Assign an element, run it once, and then use that for the rest of the loop. Get it? Right. Okay, cool. So this is the chattiness with the DOM. And then the other thing is a similar concept, which is A lot of times, you're getting the input data, and then you already know this is going to be an integer, right? So if you know that, by all means, just parse it into an integer. Don't try to just leave it away there and then try to parse it again in a loop, right? You should always just pass it into the data and then leave it in a loop. Otherwise, you're going to actually process this document, get a element by ID bench box here again, and doing the parsing again, right? So this is really something you should avoid doing it. All right, so as a result, just by doing the parse int, just assign the value, you could actually improve the 25% marshalling cost to reduce in your init function. So 25%, that's pretty crucial, right? Okay, so I'm going to skip the whole tip because we're running out of time. And I will show you the resource. Okay, so if you want to know more about that, there is a free online course you will be able to get into. It's called a Microsoft Virtual Academy. How many of you have heard about that? Okay, very good. There's a lot of free courses on different subjects, and this is just one of them. It's on the performance tuning course, and then you could get into that to watch the course. You could watch like 5 minutes at a time, or 1 hour at a time as you need. And then all the demo code, I put it on the GitHub already. This is the link, so you'll be able to get that and try the benchmark and take a look at the code. And then this is more like a complete resource where I use to develop this course. I'll just share with you. And then thank you very much.